All right, so what I want to show you how to do is balance a chemical reaction. Now, the balanced chemical reaction, or the chemical reaction that we're going to start out with, is a pretty simple and straightforward combustion reaction. So in any combustion reaction, you're going to have a hydrocarbon, C6H6 will be our example. That's going to react with O2, and a combustion reaction is great because you can always predict the products. Those products are going to be CO2 and H2O. Now, the way that we're going to balance this is the way that you can balance any chemical reaction. What I'm doing is I'm putting a line below the space in front of my reactants and my products. On the left-hand side, I have my reactants. And on the right-hand side, I have my products. Now, the way that I'm going to solve this is I'm going to use what's known as the algebraic method for balancing chemical reactions. In order to do that, what I'm going to do is I'm going to write a letter variable in front of each one of the different substances that I'm using. C6H6, O2, CO2, and H2O. So what I'm going to do is I'm going to put a lowercase letter a in front of C6H6. I'm going to put a lowercase letter b in front of O2, a lowercase letter d. I'm skipping C so we can avoid any sort of confusion there because we've got carbon and I don't want to get that mixed up. And then a lowercase letter e in front of H2O. Okay, so what I'm going to do is, and what my aim is to balance and equate the number of carbons on the reactant side as on the product side. So what I'm going to do is I'm going to write equations for each one of my elements. So what I'm going to do is I'm going to write C. C is one of my elements. C is present on both the reactants and the product side. My next element is H for hydrogen. Hydrogen is present on the reactant side and the product side. And finally, we've got oxygen, which is present on both the reactants and the product side. If you can write that, and you can do some simple algebra, you'll be able to figure out what these different lettered coefficients are. So in order to solve for my equation, or solve for the number of carbons and hydrogens and oxygens on each side, I'm going to write these simple equations. My first equation is going to center or be centered around the A coefficient. And I'm going to start that by writing 6A. Because there are 6 carbons on the left-hand side, or on the reactant side, in this molecule of C6H6. So A is my coefficient, and I'm going to use that right here, 6A, as the number of carbons that are present on the reactant side of my equation. Now my next reactant, O2, there are no carbons present there. So I'm going to write 6A is equal to, so this sums up all of the carbons that are on the left-hand side of my reaction. I'm going to set that equal to 1D, or simply the lowercase letter d, because my next molecule, or my first product, carbon dioxide, has only 1 carbon in it. So I'm going to write D. Now my next product, H2O, there are no carbons. So my first equation is 6A is equal to D. Whenever I have that, that's going to help me solve for what's the proper coefficient to put in front of C6H6 and CO2 to give me an equal number of carbons on my reactants and my product side. My next element is hydrogen. Now, if I look on the reactant side of my equation, I have 6 hydrogen in a molecule of C6H6. So I'm going to again write 6 and then A, because there are 6 hydrogens, or 6A hydrogens, on the reactant side of my equation. Now hydrogen is only found in the product H2O. So now I have to write, well, the product side of my reaction, or my equation. So I'm going to write 2E. What this tells me is that 6A is equal to 2E. And that will give me an equal number of hydrogens on the reactants and the product side of my equation. My last equation is simply going to be 2B equals to, now what I need to do is look on my product side and see which are my compounds that contain oxygen? Well, 2D plus E. There's only one oxygen in a molecule of H2O. There are two oxygens in my other product, CO2. So these are my four different equations that I'm going to use. Now all I need to do is solve for A, B, D, and E. In order to solve for that, you have to start out by defining one of them. So the first one that I'm going to define is A. I'm going to set that equal to 1 because I know that there is at least one C6H6 present in this reaction. Will that value change? It will whenever I gain more information. So I'm going to say A is equal to 1. Whenever I have information about A, well, I can look at my first equation. 6A equals D. Well, I can substitute the value that I've defined for A as 6 times 1 equals D. Or I could say D is equal to 6. So that's my first equation. I've used that. And I've solved for one of my other variables. My next equation is 6A equals 2E. Well, again, I can plug in 1 for A and set that equal to 2E. So 6 times 1 is equal to 2E, which I would divide each side by 2, divide by 2, and I'm left with E is equal to 3. Now the last variable that I need to solve for, so sorry, I've used both of these first two equations. My last value is B. So what do I need to do to solve for B? Now this equation, 2B equals 2D plus E, that's a little bit tricky because I don't have the value for B. However, I have determined my value for D and my value for E. So I can plug this in. 2B equals 2 times 6 plus 3. Well, 2 times 6 is 12, plus 3 equals 2B. So that brings me to a point where I've got 2B is equal to 15. Divide each side by 2, divide by 2, and I've got 7.5 or 15 halves. Now, one of the important parts about balancing any chemical reaction is we don't have half coefficients. We have whole number coefficients. So how can we deal with this, well, 15 halves or 15 over 2? Well, we can multiply this by 2. That will get us 15. So if we've multiplied that by 2, is there anything that we have to do to our other coefficients? Yes, we have to multiply all of these by 2. So A therefore becomes 2, B is 15, D is 12, and E is 6. So I can go back to my original balanced or unbalanced chemical reaction, that is, and I can plug in these values. And I can say my coefficient is 2 for where A was, 15 where O2 was, 12 where CO2 is, and 6 where H2O is. Now naturally, there's an idea of, well, should I check this? Absolutely. How do you check this? Well, you check this by saying, how many carbons are there on the reactant side and the product side? Well, I take my coefficient 2, and I take my number of carbons in C6H6, and I find out there are 12 carbons. Now, what about on my product side? Well, I've got 12 CO2. There's only one carbon in each CO2, so that means 12 carbons on the product side. So my carbons check out. So I'm going to put a check mark there. Now, my hydrogens, I've got 2 times my subscript, which is 6, so I've got 12 hydrogens. Then my product side, I've got 6 times 2, or 12 hydrogens on my product side. The last element that we need to be concerned with is oxygen. Well, there's a 15 coefficient and a 2 there. So that means I've got 30 oxygens. I'm going to put a slash through here so it's clear that it's 30. Now, what about on my product side? Well, I've got a 12 and I've got a 2. So that means there's 24 oxygens. Uh-oh, it's not. Oh, yes, it is, because I forgot. I've got 6 oxygens in H2O. So I'm going to say 24 plus 6 oxygens gives me 30 oxygens. So I'm balanced. I checked all of my different atoms, or all of my different elements. I used this algebraic method to come up with very simple equations where I could solve for those different values. And there we have it. That's all there is to it. You balance this chemical reaction, which otherwise was a little bit intimidating. All right, let me know if you have any questions and reach out to me on our Facebook page and we can set up a tutoring session. Thank you very much. Have a good one.